So when we talk about equivalent fractions, we can say that it's the relationship of part to whole. Okay, this is one way we can think of equivalent fractions and fractions in general. We can think of equivalent fractions that's on the same spot on or same position on a number line. Okay, so if the denominator is the size of the fractions piece, the numerator is the number of pieces. Okay, and if we have times on top, we have divide on bottom. Okay, and again, this one is one that if we can just think in this kind of simple way, we can make many math problems much easier by doing this. Okay, and for number 5, you can put in another one there for whatever other ways that you've been able to describe and look at fractions, right? Make sure that you can, if you have something that is different than what's written here, make sure you record that and note that in your notes. So here, this is called the proportional equation. It's really important to understand that this proportional equation, we're going to use this a lot for lots of things. Okay, we're going to use this a lot. But it's important to understand the relationship. It is not add and subtract. It's only times and divide. Okay, so we have times and divide relationships in these proportions. So if we increase this proportionally by a times 5 going from 3 to 15 and times 5 going from 4 to 20, we keep the same proportion, so these are equivalent fractions. Okay, so this equivalent fraction is what we call a proportional equation. And there's also the relationship going the other way. I can scale this down. I can, instead of doing groups of 5, I can do groups of 5 going the other way. Okay, so or divide by 5, go from 20 to 4, do groups of 5, 15 to 3, and we can show that these are both equivalent. Numerically they're equivalent and proportionally they're equivalent. So this scale factor or multiplying factor or dividing factor is really important to understand. This always exists. Sometimes we kind of imply it, but it always exists. And if I'm going to times in one direction, I have to know that I could always divide by the same factor in the other direction. And this idea of opposites. Okay, this idea of opposites is also a very fundamental idea in math. These are really important points in math. This times is opposite of divide. Okay, times one way, divide the other. Okay, so why can we have different fractions or fractions in different terms be equivalent? Why? It's really important to be able to articulate this. So it's important to understand that the proportions are always going to be the same. So if these are proportionally, this is important, proportionally the same. Okay? This word proportionally is important because it implies this idea of the same rates and proportions, okay, or the same times and divide. Okay, so, and maybe I should even state that. So the times and divide is the same. Times and divide are the same on top and bottom. Okay. They can be equivalent another way. We can think of this as, well, if I actually divide these two numbers, 3 divided by 4 and get a decimal, and go 15 divided by 20, I get the same decimal. So I can say that if we divide, okay, because this is what fraction bar means, it means to divide. If we divide, we get the exact same number. Okay, so that's also important. And what we could also say is that they show up on the same point on the number line. They appear in the same position Okay, so they appear in the same position on the number line.